Okay, welcome everybody to part 2 of ContraBIM's AEC guide to Google Earth. Today we're going to be talking all about measurements and using the ruler tool to get different measurements and save different measurements of all different types of features within Google Earth. So we're going to be talking about lines, paths, polygons, circles, which all really clamp to the ground level of the Google Earth working environment. And then we're also going to talk about the 3D paths and 3D polygons, which allow us to snap to other features that are such as 3D buildings and different elements that have been mapped to a greater level of detail in 3D. So we'll talk about the 3D measurements as well, and then we'll close things off with talking about different place marks, which allow us to save specific coordinates and altitudes and take those things and export them out or share them to other people who want to use Google Earth. So, okay, so before we really jump into it, one thing we need to make sure that we have turned on is our status bar. So up under view, let's just make sure the status bar is checked. And what that is that's this panel down here on the very bottom right corner, which essentially gives us our coordinate at any specific point and our elevation at that same point. So the thing that it's measuring right now is actually just right where I'm hovering my mouse. So we can see that out in the ocean, we actually have a negative elevation because that's essentially clamping to the seafloor. And then as we come over the land, we can see that that elevation jumps up right away to, hundreds of feet to thousands of feet, all the way over to, the plains where we're back down to just a few hundred feet. And then on the other side, the Atlantic, we're back in the ocean. So of course we're back negative. So, okay. So, let's talk a little bit more about altitudes and elevations. And to do so, let's just kind of, maybe we'll zoom in and let's check out maybe San Francisco, and we'll start here at the Golden Gate Bridge. So one thing to note is there's really two main different types of views of looking at the terrain and 3D elements within Google Earth. So one is with the 3D buildings turned on, and one is with them turned off. So if we whenever you're looking at trying to get elevations out of Google Earth, you certainly want to have your terrain turned on. That's a must. So if we toggle that off, we can see that everything just gets flattened out, and anywhere that I hover with my mouse, it's always going to be just stuck to essentially to zero. So whenever we're trying to do elevations, we want to really make sure that that terrain's turned on, and that's going to give us a much more accurate mapping of the values out here as well. So, but like I said, there's two different levels of detail that we have to work with. So one is based off of actually just the clamped to ground value, which you can view actually by turning off the 3D buildings. So we'll do that right now. And so you can see that all these hills right here, they're still mapped pretty close to as if they were turned on. If we toggle that back and forth, you can see that the imagery changed. It's actually a much brighter image to have the 3D building textures turned on. But if we turn that off, essentially the mapping of these terrains here is very, very similar to that of when it's turned on. So, but one of the big things to note here, so this the Golden Gate Bridge is a really good example of this. If we turn off our 3D buildings, we'll see what is actually mapped to the ground level. And so that's a good example of the difference between using the line, path, polygon, and circle. All these four will clamp essentially to this surface that we're looking at without our 3D buildings turned on. And then to turn on the 3D buildings, these last two tools are the only tools that will really stick to those surfaces. So say for example with a line, if I was trying to measure from this point to the other end of the bridge, to that point right there, I couldn't do that with a line. It's actually clamping that directly down to the bottom of the ocean in this case, or the seafloor. So we can save that, just drop it into our temporary places. So the big difference is if we wanted to actually take that measurement, what I would do is I would go with a 3D path, and then the 3D path allows us to actually stick to those points, and we can do just maybe one in the middle there to get that elevation, and then one on this side. And so that's a much better representation of that length measurement that we were looking at there. So if we actually turn off our 3D buildings, you can see where those points actually snap to. and when we turn them back on, you'll see that it'll do a little bit of an adjustment. What's actually interesting there is just the difference in how it interpreted that when you turned off the 3D building. So we can see that it's much more accurate actually when they're turned on, in this case using the 3D path tools. So okay, so we can save that one as well. Anytime I save these, I either want to I always want to change to whatever units of measurement that I'm looking for. So in this case, miles is probably a good unit of measure, and so I'm just going to type in 1.23 miles, and there we go. It'll save it to our temporary places, and then if we wanted to save that so that it's available the next time we open up Google Earth, we would just have to save those to My Places. So we'll leave them down here for now. Okay, so we'll turn both those off. Okay, so next let's talk a little bit about the specific tools under our ruler, and we'll go into a little bit more detail about the most basic measurement, which is a line measurement. So what the line essentially allows us to do is it's a straight point. So say for example, if I want to measure a between 2 points, I would just click and then drag and then measure the specific length of that area or that path. So at any point we could grab those the nodes on either end, and you could tell when you're on a node by it'll change to the hand icon, and then you can just click, hold it down, and then you can drag those points around to be able to move that measurement to a specific point. So one thing to note here is right now I'm moving with a 3D mouse, which actually frees up my other hand to be doing different inputs at the same time. So that makes it really, really nice if you're doing a lot of measurements to have a 3D mouse and be able to use both at the same time. But if you're not using a 3D mouse, then you just want to make sure you have your mouse navigation turned on so that at any point you can take your view, you can rotate it around, you can zoom in, you can grab these nodes, pan, grab the other node, and move it around and do all that while you're in the input method. So we don't have to finish any of these before we modify it. We can do that right on the fly with this mouse navigation turned on. So if we turn that off, we can see now that I can't do anything. I actually just reset my measurement there when I was trying to click and rotate. So yeah, there's nothing I can do right now to really, actually I can still zoom. That's the one thing I have, but I can't pan or I can't orbit around, change my viewpoint. So okay, so with that, let's go ahead and turn that back on, and then again we can see that we can very easily just rotate around and change our view. So okay, so for our line tool, we have both a map length as well as a ground length, and it also gives us a heading, which is kind of nice. But those two measurements are typically going to be the same if it's a very flat surface, such as down here. This looks pretty flat, so I would expect those are going to be exactly the same. But if we move over to something with maybe a little bit more elevation, like this road heading into that tunnel there, if we click from a point down here up to that top point, we can see that the difference between these is going to start changing, because that's adding actually the difference in altitude there as well. So it's doing a more cumulative measurement of the ground length versus just the map length. So okay, so let's clear that. So the line is essentially our most basic measurement, and again, if you turn off your 3D buildings, this is really the surface that we're snapping to anytime that we're using these four inputs. So it's really important to understand really the difference between this surface when you're doing these measurements and having those 3D buildings turned on, because that's going to in some cases could drastically change your input method. So okay, so let's talk a little bit, let's go to the next step, which is the path tool, which I use all the time for doing larger measurements. Say if I wanted to map out the I don't know, we'll just go in and we'll pick a path here. So maybe if I wanted to map out like a walkthrough, I guess this looks like a cemetery here. With the path tool, the main difference between that and a line is it essentially allows you to do multiple inputs. So it allows you to really trace out specific lengths, and you're not limited to just 2 single points. So we can trace those lengths out. We can go in and we can grab those points and modify them later. And anytime you have a blue node, essentially the next click that you do is going to add it in after that blue node. So if I wanted to add a point right here, I could just click and add it. But if I wanted to add a point back right here, I couldn't do that from my current state because it's going to add it on the other side. I'd have to click back here and then add it in between those last 2 nodes. So one thing to really pay attention to. But one other feature that's really cool about the path is that it allows us to actually turn on our a profile of that, and then it kind of changed my zoom there, but I'm going to get to a better view here. And so what this allows us to do is really it creates a profile of that entire path, and so it gives us our bottom elevation, or actually percentage slope at any particular point along that path, and then our total distance as we move along that path as well. So it's adding up our total distance and giving us the length to the point at the very top here. So okay, so that's it could be really interesting for measuring out different, say, hikes through going up mountain passes, or just different elevations. There's a lot of different things you can do with this tool, and it's nice that it gives you that really live feedback as you're going up and down. At the top bar here, it gives us our total distance, total elevation gain or loss, and our max slope and our average slope. So again, it summarizes up between the first point here and the bottom point, and we can take these and drag them around, and we can see how that's impacting the profile of that. So it's pretty interesting to be able to take these, and as we kind of drag it over different features, we can see that it's really changing a lot of different points in that profile. So it's pretty interesting to look at that, and we can do this over as big of a scale as we want. So take it all the way up and over a mountain pass there, or over the Sierras, and so we can see that now we're up like 12,000 feet through that one particular location. So okay, so I'm going to go ahead and clear that. We'll turn off our elevation profile, and let's come back in here. One thing I noticed is sometimes when you're in the input, and you can see how my horizon got a little messed up there. If you ever get sometimes within an input of a measurement, sometimes you can get thrown off axis like this. So if you just hit your north, what that's going to do is it's going to flatten us out, and we should be okay for going to our next input. So okay, so let's just zoom in here. Let's find, say, a good project site. So that one looks pretty good right there. That actually looks like a actual construction site. So okay, so let's go to our polygon tool here. And so the polygon is really what you would want to use if you want to create specific area measurements. So if we wanted to understand the size of this site, I would just come in here, and I'm going to just start clicking around, and we'll get the overall on that site. Looks like a construction trailer there, and we'll just click around, and okay, so there we go. We have our total. It gives us a perimeter. So in this case, if I had fencing on that site, I'd have about 2,119 feet. I could change this unit of measurement, of course. I'm going to leave it as feet in this case. Under my area, I have my square feet here, or I could change this to acres or any other unit of measure. In this case, I'll probably just leave it as square feet. And okay, so from this point, that's a nice measurement. It's a good way of analyzing a site, and very useful units of measurement if you're, say, trying to size up a logistics plan, or understanding how much grading you might have in this particular case. So we can go ahead and we'll save that. We'll go to our measurements, and anytime we save a measurement, you want to just go in and check what your units are. This will default. If you're doing a polygon, it's going to essentially convert that measurement to the polygon tool. If you're doing a path, it's going to obviously convert it to a path tool, or a line will go to a path as well. And so it'll default to whatever those units of measurement are that you have set up in those tools themselves. So that's why we need to go in this case, and we will just change this to the units we want. And I'm going to just call this 2 120 2,120 linear feet and 186.8 thousand square feet. So, okay, there we go. That makes it really easy if I want to just see what that measurement is. We can toggle it on and off, and without having to go in to see what those properties are, I have it saved right in the name. So that's just a nice quick reference. I could, of course, add another link, image, add a local image, and I could understand some other things about that as well once it's inputted. But we're going to talk a lot more about doing different measurements and different modeling techniques within Google Earth in the next part of this tutorial series. And so yeah, stay tuned for that. We're going to talk a lot about how to create different shapes within Google Earth and understand different measurements coming out of those. So okay, so I'm going to just hit OK there. We can see that we actually elevated that up and kind of created a 3D shape. But okay, so let's move on, and we'll go now to the next measurement, which is a circle. And so a lot of the time I'll use a circle, say if I'm trying to understand like a total distance from, say, a project site. So, you know, if we go somewhere downtown here, if I just start zooming out and pulling this radius out, we can see what the length is here. So our most appropriate measurement in this case is probably going to miles. And so this gives us essentially what 100 miles radius looks like in this case. So I can click and snap that, and then that's essentially stuck in that view. So I can always take that and by grabbing that node right where this point comes out, I can take that and adjust it as well. So say if I wanted to understand what 500 miles look like, I could do that. And something that's really useful just for like a real quick understanding of different radiuses or locations from a specific city or location. So at the same time, it's going to calculate the area for us. So what is that, like 22 trillion square feet? Probably go to acres, or maybe miles is more appropriate. And as we drag this down and get closer and closer, we can really see what, say, maybe 20 mile radius looks like, and 1,300 square miles within that perimeter. Circumference, 128 miles in this case, which really isn't that useful of a measurement for this type of analysis. But if we come in here and say we want to look at something that's round like this, we can go in, and using that same circle tool, maybe that's a little bit of a quicker measurement to try to understand the perimeter of something that's round. And we can take this circle and drag it around just by grabbing that center point. And so again, that's another way of modifying specific points. I'm trying to, maybe we'll go right here. This might be interesting. If we go to, say, home base in this particular scenario, I could take this point, and from this point I could start understanding really what those lengths are. Kind of an interesting way of looking at this. Change this to feet so I can see in this ballpark to the wall. We can just kind of take that, measure it out, and really see what the those max distances are to some of those particular points within the ballpark here. So okay, all right. So let's move on now, and let's talk a little bit more about some of the 3D measurement tools, because they are actually really kind of interesting for doing measurements of specific buildings. So let's see here. Let's find, say, a length that we want to measure. So I kind of like looking at the stadium here. So say if I wanted to understand the length to measure from one side of the park to the other side, I'd want to use a 3D path in this case, because if I turn off my 3D buildings, essentially if I was using the normal path, it would be sticking to this particular surface here. So if I turn on my 3D buildings, that's going to allow me to actually stick to these map surfaces. So say to walk from one side of the stadium over to another, I could just go through and click this out, and we'll do that quick measurement. And so that's kind of an interesting way of measuring 3D elements within the Google Earth environment. So if I turn that off, we can actually see that that elevation is actually stuck up there. But I've noticed when you toggle that off, it tries to kind of fit it in a general elevation above the ground level. So when we toggle this back, you can see right now it's kind of going up and down a little bit. If we turn that back on, you can see that that'll kind of flatten out and stick to that actual elevation, which is, in this case, we can see it's much flatter than what we were getting when we had the other terrain toggled. So okay, so we can save that. So next step here is say if we wanted to measure the size of something, we would want to use the 3D polygon. So the path again is for length. Polygon gives us our perimeter, so our linear footage of the length around the shape that we trace out, as well as our areas. So say if we wanted to understand the area of this electronic or the scoreboard, sometimes it's kind of tough to get it to stick to things. So sometimes you have to kind of navigate around to actually get it to stick to those certain points. And so that allows us to actually snap and get an area of that entire surface. So it gives us our perimeter as well as our area. So we can save that and use that later as well. Okay, so I think with that we've gone through pretty much all the different ruler input methods. So just one more time for clarity, the line, path, polygon, and circle are all based on clamping to the surface without having the 3D buildings turned on. And then the 3D path and 3D polygon are our measurements for actually snapping to certain features based on this terrain mapping. So, okay, so one last measurement tool that I want to talk about here is the actual Placemark tool, which is really helpful for understanding elevations at a particular location. So say, let's come in here, let's try to find a blank project site. So, okay, that looks like one right there. Actually looks like a site where they demoed something and they're now going to start building something. So say if I wanted to understand the elevation as we enter this site right here, this Placemark is a really good way of communicating coordinates and information back and forth from Google Earth to other modeling applications. Actually, in the later part of this series, we're going to be talking about taking these Placemarks and importing coordinates into ArchiCAD, which is a really good platform for taking content back and forth from Google Earth with. So understanding the Placemark is really important, and specifically the altitude. So there's a few different settings that we have here under altitude with these Placemarks. By default, we're set to clamp to ground. And so anywhere that I drag this, it's going to automatically just clamp directly to that ground surface. And in this case, it's actually going to be clamping to the surface. Actually, oh, that must be the new building in this case. So it's going to be clamping to this particular surface. So that's one thing to understand, is that it works off of the base ground surface within Google Earth. So let's turn this back on. And yeah, so our next setting here is we can either go clamp to ground or clamp to seafloor. In this case, because we're on the land, it treats the seafloor essentially the same as the ground. But if we go to relative to ground, then that actually gives us the ability to take that Placemark, and just by dragging this toggle switch, if we're at 0, that's clamped to the ground, and then relative means that we can go above. So as we zoom out a little bit, we can see that it's changing our altitude based on the dragging the toggle bar here. And if we click extend to ground, it actually gives us a little bit of a line that shows us that measurement from that particular point. So okay, so this next is relative to seafloor, so that essentially gets treated exactly the same. But the final one is really the one that I like using the most, because this is the best method for actually saving out coordinates. Is you want to always do it in an absolute value, because that just it carries better elevation data for when to import that into different programs. So whenever you're saving it out, just make sure that you're set to absolute, and then you should be good to go for taking this and exporting it out. So, okay, one thing to note here is right now I'm on absolute, but I'm on extend to ground. And so one thing we want to do is right now we can see that we can't actually see that pin, so it's actually clamping down to a level that's below this particular location. So, and we can see that better when we're zoomed in a little closer. So if we turn on track cursor height though, and then we start dragging this around, we can see that now it's going to actually change our elevation based on where our mouse is cursoring over. So in this particular location, we have two visual feedbacks that we're getting. One is the altitude that we're getting within our place mark itself. So you can see that change from one to another. And then the other option that we have is again down here under our status bar, which is elevation in feet. So it's really kind of interesting to be able to have both of these at once, and yeah, understanding the difference between the place mark elevation and our elevation where our mouse is. So okay, so at this point I'm just going to at the entry of that site, I'm just gonna hold it right there. I'm at 13 feet and 4 meters, so I'm just gonna call this 13 feet 4 meters, 2 units of measurement. And so it's interesting to be able to have both of those when you're saving it out. Just a good reference, just to have when you're working with this later. So okay, we'll hit OK there, and there we go. So that's pretty much it for the different tools of measurement. We could always come in and we could click a point, and if we wanted to understand the height of a building, we could change this to absolute. And again, I'm going to do track cursor height. So at the ground here, I'm at 6 meters. And if I wanted to understand the height above sea level, or the absolute value of this, I could see, I don't think it's going to click. Actually, it did click right there. So just by having the extend to ground and track cursor height, this will actually give me the ability to come up here and snap a point, and I'm getting both the elevation value as well as the metered value at the same time. So I could do that and call this 362 feet, 110 meters, and parapet. Okay, so now that's saved in there, and I can always go back and reference that. So if I wanted to take these place marks and save them out, I would just do a save place as. And also you can always go back and click on any of these elements that we save under our places. And if you double click, it's just going to take you on an automatic zoom to that. So for this location, if I do save place as, I can just save this out as a KMZ file, and then you can take that KMZ file and either email it to someone or again use that as a method for importing coordinates into another 3D modeling software. So we'll talk more about that in a later part of this tutorial series. But okay, so that's pretty much it for measurements. And again, we're mainly working with a ruler here. Really, it's important to understand the difference between having 3D buildings turned on and turned off. Always make sure you have your terrain turned on. And yeah, you can get a lot of really great feedback just by hovering over things and looking at our elevation status bar function right down there. So, okay, so with that, I'm going to go ahead and wrap this video up. Thank you for checking it out. Hopefully you learned some new tips on how to do different measurements within Google Earth. There's really unlimited amounts of functions for doing this, such as measuring out different paths for trucking routes, tracing over different utilities that you want to survey on a site, or tracing over buildings to understand either their surface areas or different lengths of specific features of them. And there's really a lot of different things we can do with saving out different views, different place marks, saving different measurements, and communicating different things within Google Earth just by tracing over what's available to us in the working environment. So, okay, thanks again for checking this out, and stay tuned for part 3, which is a series on or a tutorial on all about how to do different 2D and 3D modeling. So there's going to be a lot of really cool modeling techniques just to set up some real basic shapes within Google Earth, and we can do some different cool site plans and site analysis with that. So, okay, thanks for watching, and we'll catch you on the next video.